Mpirical provide compelling, interactive learning across a range of delivery options. Live on site, live online, or online anytime, we have a training course that is ideal for you. For a no-obligations chat about your training requirements, contact us at mpirical.com.
In this look at the core network, we're going to focus in on two main areas. To begin with, the notion of evolved packet system bearers, EPS bearers, and then the actual key components of the evolved packet core. So this is the end-to-end architectural view of the network. We know it's comprised of the EUTRAN, the radio access network, and the evolved packet core, and collectively we have the evolved packet system. Now, this is there to connect our device to a packet data network of some description, the primary example being the internet, but it could be the IMS for example, VoLTE services, or there could be other examples of packet data networks. Now, the connectivity that is in place between the phone and the packet data network is called an evolved packet system bearer, an EPS bearer. So this is what we have. So phone to packet data network is this notion of an EPS bearer, and there are actually two different kinds of EPS bearer available. The term given to them is the default EPS bearer and the dedicated EPS bearer. And the first point to note about these EPS bearers is the default bearer is always the first bearer to be established to a particular packet data network. So if I switch my phone on and I connect to the internet, the first bearer that has been established in the network for me is my default. Now, if for whatever reason the default bearer doesn't give me the correct quality of service I need for the particular traffic that I'm sending, it's quite possible that a dedicated bearer will be set up. And the dedicated bearer is linked directly to the default that came before it. So here's the distinction. The distinction is that dedicated bearers are only established if the default doesn't have the correct QoS characteristics for the traffic that I'm sending. Now, the internet as an example packet data network is probably not a good example of where you would see default and dedicated bearers, because for the most part, subscribers who connect to the internet largely send all of their traffic down the default bearer. If you use VoLTE as an example though, VoLTE is a good example of where you would see default and dedicated bearers in use, because with VoLTE, voice over LTE, the default bearer would carry all of your signaling to set up the calls, but because signaling has got a totally different QoS profile to voice, you would need a dedicated bearer in place to carry your voice when you're in the middle of a phone call. So just some key points to note. There's only one default EPS bearer per PDN connection in place. So if I'm connected to 3 different packet data networks, I would have 3 separate default EPS bearers, one for each of them. You can have multiple dedicated bearers, so they can be established per PDN, and each of them would have to have different QoS. So again, getting back to the VoLTE example, it could actually be a video, a ViLTE call. So you would use the default bearer to carry signaling, you would need one dedicated bearer to carry voice, and another dedicated bearer to carry video, because voice and video have got different QoS characteristics. Final point to note, the default bearer must always be established before the dedicated bearer. And it's this bearer, this notion of a bearer, that essentially carries our IP traffic from the phone to the packet data network or vice versa. It's also worth remembering that this bearer, or bearers, depending on the situation, are unique to the subscriber. So these bearers aren't shared by multiple subscribers. They're unique to the subscriber. And if you're already aware of 2G and 3G, the concept of an EPS bearer is similar to a PDP context in GPRS. Now, in terms of the connectivity in the network, you can see the end-to-end bearer is comprised of the mobile, the eNode B, the serving gateway and the PDN gateway. And in order to actually establish that EPS bearer, what you actually need to do is set up point-to-point connections between each of the network elements that are involved. So every time you set up an EPS bearer, for every subscriber, you need to set up these three separate connections. Phone to eNode B to serving gateway to PDN gateway. The way in which they are set up, the specific procedure for your reference, to set up the default bearer is the PDN connectivity request procedure, and to set up the dedicated bearer is usually a network-initiated dedicated EPS bearer establishment process. Sometimes the phone can set the bearer up, but that is very rarely seen. The establishment of a dedicated bearer is usually triggered from the network. Now, the APN is important. The access point name identifies the packet data network that we are actually connecting to. So when we do set up a default bearer to a specific packet data network, the LTE network needs to know the APN. So which packet data network are you actually trying to connect to? So this is part of the attach process. When that phone connects up to the network, it will tell the network which APN, which access point name it wishes to connect to. So you can see some example formats of APNs up on the screen here. The two most prevalent will be the Internet and the IMS APN. So if we start looking at our network architecture in more detail, remember we're not focused on the eUtran element, we're only focused on the evolved packet core. And this is our architectural reference model. It includes all of the reference points. Notice that some of the reference points, the links between the different nodes, are different colours. So we've got some blue reference points here. That's got no technical relevance, it's just coloured because lines are crossing in the diagram. Really, the main areas of focus that we're going to look at are the MME, the serving gateway, the HSS and the PDN gateway. And we're going to start with the role of the MME. It's the mobility management entity, and it's really got two main roles, mobility management and session management. So at any given time, as long as you're attached to the network, the MME will have a rough idea as to where you are located. So when you are in an idle mode, the MME, in terms of subscriber mobility, will know the tracking area that you are currently in. And as soon as you get into a connected mode where you are actively talking to the network, the MME will know the cell that you're currently in. In terms of data sessions or session management, the MME will be involved in setting up your EPS bearers. So when you connect to different packet data networks, the MME will have an involvement in that to ensure that you are allowed to actually connect to those packet data networks in the first instance. But generally, mobility management, all in terms of subscriber mobility, and session management, all in terms of the data sessions being established, are the main roles and responsibilities of our MME. Now, as we move back to our architectural diagram, the next element that we're going to cover is the serving gateway. And we already know that the serving gateway is involved in the end-to-end EPS bearer path. Now, specifically, it's involved with user data anchoring for the eUtran. As you can appreciate, LTE is a mobile network, so we can move around the network and be handed over from one eNode B to another. However, we must have an anchor point back into the evolved packet core. So although we're swapping from one eNode B to another, those eNode Bs will be feeding and receiving traffic back to the EPC or from the EPC via our serving gateway. It's really the entry point or exit point of our EPC in relation to our eNode Bs. Another key responsibility of the serving gateway is data buffering, and this is all because of the paging process. So when the device is in idle, when the device is not actively doing anything, it's quite possible that data could come into the network destined for the device. So while we go through the paging process to find out where the device actually is and get them up online into a connected state, Any data that comes into the network has got to be buffered at the serving gateway. So it's really important that the paging process happens quickly so that we're not trying to buffer too much downlink data for our subscriber. Moving back to the architectural diagram, the next element that we've got to consider is the PDN gateway. Now notice, if we just go back, there are two PDN gateways in this diagram, which is perfectly permissible. It really just depends on which PDN gateways connect to which packet data networks, represented by APNs. So the PDN gateway's roles and responsibilities include, once again, user data anchoring. Remember, the PDN gateway is on the data path for the EPS bearer. Now, the PDN gateway is really the entry point and the exit point for the network in relation to the PDN that we are connecting to. So as we move around the network, we've already said that we can change from one eNode B to another. It is quite possible that we can actually swap serving gateways as well in some scenarios. But what won't change for the duration of my attachment to that packet data network is the PDN gateway. It is the anchor point for that PDN. The PDN gateway is also responsible for policy enforcement as well. So the PDN gateway will actually be in communication with a device called the policy and charging rules function. Basically, when the subscriber wishes to do something, even as simple as attaching to the network, the PDN gateway can implement policy to maybe change what the subscriber's service ultimately looks like. So for example, if the subscriber's on some kind of tariff, which means that at times of heavy network congestion, their data rate is lowered, then the PDN gateway, when that subscriber attaches to the network, will lower their data rate. But there are numerous examples of why the PDN gateway could get involved with policy enforcement. The PDN gateway is a key point for billing as well, so it will generate CDRs and send them to the appropriate billing platforms. If we're talking about prepaid credit, online charging services, the PDN gateway can decrement credit as and when our subscriber uses their data allowance. And then finally, because the PDN gateway is connected to the packet data network, the internet or the IMS or whatever else, it's the prime point for IP address allocation. So it will be giving the subscriber device its IP address that it needs to use on the packet data network as appropriate. The final element that we need to consider in our Evolved Packet Core architecture is the home subscriber server. And really this is the central repository of subscriber information. So what kind of information is that? Well, the HSS knows at the very least the subscriber status. Are they allowed access to the network, service granted? Are they barred? The HSS will know which packet data networks our subscriber is allowed to connect to. It will know which, in other words, APN they are allowed to connect to. So for example, if they are only an internet user, they will only be allowed to connect to the internet APN. But if they're also a VoLTE user, well, they'll be allowed to connect to the IMS APN as well as the internet APN. The HSS is also associated with permitted QoS. So when we do connect to a particular packet data network, you will have a specific QoS profile. So the HSS stores what that profile is and provides it to the MME as appropriate. So the MME can ensure that the correct EPS bearer with the correct quality of service is established. Roaming permissions are also stored in the HSS, so the HSS is a key element involved with the roaming process. So it will determine if a request comes in from a visited network for a subscriber who is roaming, the HSS will determine whether or not they are actually allowed to roam and what kind of roaming is indeed allowed to take place. Maximum bitrate, which I suppose is partly associated with quality of service, is also stored at the HSS. This will be maximum bitrate on an overall basis and also maximum bitrate on an individual APN or PDN connection basis. And then finally, security credentials. So whenever we attach to the network, there's a whole host of different security that's established, and the central point to it is the storage of security credentials at the HSS and on board the device itself. So just in summary then, we saw that the EPS bearers flow from the mobile through the eNode B onto the serving gateway and then out through the PDN gateway to the packet data network. And obviously this is bidirectional. We get two kinds of EPS bearer, default and dedicated EPS bearers. The default is set up first and the dedicated is only set up if the QoS of the default isn't good for the traffic. Dedicated bearers are much more transient. The key components of the Evolved Packet Core, well, they included the Mobility Management Entity, which looks after mobility management and session management, the Serving Gateway, which looks after eUtran anchoring and also data buffering for paging purposes, the Packet Data Network, which we saw as our anchor point to the Packet Data Network, and it also does things like policy control and IP address allocation, and our Home Subscriber Server, which is our central repository of subscriber information.
Need to know more? Why not visit our store where you can choose from over 200 hours of video-based training. Alternatively, you can contact us to discuss any specific training requirements you may have.